Flirting with around freezing temperatures. Should be relatively dry as we go through the night. Hi, I'm Chris.
Hi, I'm Sean, and this is Weather Booth.
Let's talk about tornadoes today. Where and how do tornadoes form? How do we forecast tornadoes? How can we be safe from tornadoes? These topics will be covered in today's special episode covering severe weather in the weather booth.
There's a lot that goes into tornado forecasting. For the purposes of this episode, we're going to stick to the basics. A tornado, as defined by the American Meteorological Society, is a, quote, rapidly rotating column of air extending vertically from the surface to the base of a cumuliform cloud, often with near surface circulating debris or dust when over land or spray when over water.
Tornadoes usually form within a rotating supercell thunderstorm, and they can vary significantly in wind speed. Small tornadoes can have maximum wind speeds around 50 miles an hour, but the maximum recorded wind speed in a tornado is 302 miles an hour in Bridge Creek, Oklahoma. Far stronger than the strongest hurricane ever recorded.
Definitely. That's some of the strongest winds in the entire solar system, as long as you don't pay attention to Neptune. That's out of this world. So approximately 75% of the world's tornadoes occur right here in the United States each year. So it is extremely important for US citizens to be prepared for a tornado at all times, especially during the severe weather season. Even if you don't live in the Great Plains, known as Tornado Alley, you should still heed this information because every state has recorded a tornado at some point. So for my segment, I'm going to talk about some interesting extreme tornado facts, as well as focusing on the deadliest tornado in US history. So here's some interesting facts about tornadoes, in terms of extremes at least. The most tornadoes ever in a 24-hour period occurred in 2011 during the super outbreak that affected both the US and Canada. There are a total of 360 tornadoes in a 24-hour time span, and 15 of which were an EF4 or greater in magnitude.
That's insane.
That's a lot. That's a lot.
I knew that tornado outbreak was bad, but I didn't know it was that bad. That's almost like one tornado per day, just in a 3-day span. If you were to extend it over a year.
Indubitably. The most damaging tornado in the US at least occurred in Joplin, Missouri on May 22nd, 2011. So we're coming up on the 10-year mark. In terms of its cost, it came up to a bill of $3.182 billion adjusted for today's inflation. That's a very costly tornado.
That's like,
and that's the one single tornado that hit Joplin, not even an entire outbreak.
Some of the stronger hurricanes, I mean, they are on the order of billions of dollars in damages, but hurricanes are also much larger than tornadoes.
Yeah, like I think like Hurricane Katrina, which is obviously one of the most costly hurricanes. We'll get to this in a future episode. That came to like $100 and something billion. So to think that a single tornado was $3 billion and it just hit one city, whereas Katrina obviously hit several states and stuff, like that just shows you how much of a punch a tornado can hit on a community.
Tornadoes are really, really damaging. We're going to get into this.
Definitely. And the deadliest single tornado in US history was the Tri-State tornado, which occurred on March 18th, 1925, which we're coming up on the 96th anniversary of it.
Wow.
It had a total of 695 fatalities, which, for reference, the second deadliest tornado outbreak in US history occurred in 1840. So we have to go back way further than that. And that killed 317. So the deadliest tornado in US history killed double the number of people as the next highest ranking tornado.
Wow.
So this is especially damaging. So we're going to talk a little bit more about the Tri-State tornado, which occurred in 1925, because I feel like aside from its like insane death toll, just like how it progressed throughout that afternoon, that one March day, it's incredible to hear some of these stories. So this was actually also the second deadliest tornado in world history after the Dolapur tornado that struck Bangladesh in April of 1989. That one tornado in Bangladesh killed 1,300 people. So obviously the infrastructure and development is different in Bangladesh, even going back into the late 80s. So with proper warnings, as we can probably discuss later in this episode, also help reduce death tolls. We
Absolutely.
definitely don't see these high death tolls nowadays, thankfully.
No. Thanks to tornado forecasting nowadays and warnings and stuff.
So here's the tri-state tornado. So it started in Missouri, in southern Missouri, at around 1 p.m. and it would last for 3.5 hours, having a path stretching 219 miles or 352 kilometers for literally anyone else in the world. And that means that it traveled about 70 miles per hour. And like that's a very fast moving tornado.
It's like me
Coming up
driving down
on.
the interstate.
Yeah. And back then they didn't have interstate, so they'd be like, oh no. So let's break it down by state. The 3 states impacted were Missouri, Illinois, and Indiana were dissipated. So let's break down each state. So in Missouri, as I mentioned earlier, it was first seen around 1:30. And when it was first sighted, it was a small condensation funnel cloud in Shannon County, Missouri. Shortly thereafter, the first fatality was sadly recorded. It was a farmer in Reynolds County who was taken off guard by the impending storm. As the tornado continued to move northeast, the twister hit the mining town of Annapolis, which had 90% of its township leveled. So 10% of the buildings were left standing. That's incredible. Like having a whole town just like decimated.
That's the power of tornado.
It's almost like a nuclear bomb hitting, just like leveling it. So as it continued to move northeast through southern Missouri, it hit Bollinger County. The tornado injured 32 children who were trapped in 2 of the schools that were damaged by the passing tornado. I didn't see any information about whether or not there were many fatalities in this incident. I'm hoping that those 32 children all made it out fine.
Me too.
And then before it left Missouri, it went through the mining town of Sedgwickville, and it picked up iron sheets, so like big, heavy iron sheets, and they were later found as far as 50 miles away. This tornado carried these big iron sheets 50 miles. Yeah. So once it left Missouri, it went into Illinois and crossed the Mississippi River. And the tornado was going through many like rural communities at this point, or in like open swaths of forest. And after the storm, they found many of the trees had their bark completely ripped off, and the ground was completely like leveled. Like all vegetation was just like, it was pretty much the earth was revealed underneath all of it as a result. The riverside town of Gorham was hit at 2:30, and the entire town was obliterated. Half of the entire town's population was either killed or injured as a result of the passing tornado. So as this twister continued traveling to the northeast, it became wider and had a nearly 1 mile wide path as it hit the city of Murfreesboro. So Murfreesboro is one of the largest communities to be hit by this tornado. It had about a population of 10,000 at the time. So it demolished a lot of the city. But what was especially worse is after the tornado had since passed to the northeast, fires began to break out in the city. And many of the people who were trapped in the rubble succumbed to the flames because the response wasn't quick enough to put out the fires and rescue the people. So the death toll continued to accumulate even once the storm was out of the vicinity. 1/3 of the fatalities from the entire storm occurred in Murfreesboro, where 234 people lost their lives. And this continues to hold as the single highest death toll for any US city contributed to a tornado. So as we were mentioning, warnings are definitely very vital in saving lives nowadays.
Tornadoes are so powerful.
It's insane.
I've never seen a tornado. I don't want to see a tornado.
Yeah. If I ever see a tornado, I want to be a nice safe distance. That's all I will say. So finally, after it left Illinois, the last state it moved into was Indiana. And it took nearly an hour for the storm to pass through Illinois and cross into Indiana. This town of Griffin was entirely obliterated by this tornado, and 46 people died in the town. By 4:38 p.m., this tornado dissipated and left a 219, I think, mile. I lost track of. Yeah, 219-mile path in its wake. So let's see. So obviously, the impact of a tornado doesn't just occur right when the storm happens. As I mentioned, the fire that broke afterwards took more lives. So in the aftermath of this storm, hospitals within the vicinity of the path were inundated with the injured and dying, with more than 2,000 people having been injured as a result of the tornado. Several of the rural communities that were impacted by the storm never recovered, and the ones that were nearly entirely obliterated tended to never rebuild, and much of its surviving population moved elsewhere. Modern estimates for the storm place its top speed at about 300 miles per hour in some locations along its path. There are no actual photographs from the storm, but the tornado has frequently been described by its witnesses as an amorphous rolling fog or a boiling cloud, which like continued across the ground and fooled normal weather-wise farm owners who did not sense that there was as much danger with the storm. So the tornado didn't appear as like the typical tornado. It was like much clouded and had some like mysterious element to it that even wise farmers who knew what to expect from these type of storms were caught off guard. So in 2013, meteorologists actually had they published a paper where they analyzed the specific tri-state tornado. And they determined that some of the factors that went into this being exceptionally deadly, aside from it taking place before warning systems were prominent, was that the winter, because as I said, this happened in mid-March, so it's the very tail end of winter heading into spring. But the winter was actually pretty mild at the beginning of 1925, and it was also drier. There was a persistent ridge over the western US, which allowed for a trough to continually be in place throughout the central plains. And the tri-state supercell, which obviously formed the tornado, is thought to have formed around noon on March 18th, and about 40 minutes prior to when the first tornado was sighted in Shannon County, as I mentioned at the top of the segment. It was a classic supercell, according to the 2013 report, for which the first couple hours of its life, the supercell gradually transitioned into a high precipitation supercell within southern Illinois. The very long track tornado would then, which had a period from about 12:40 p.m. to 4:40. So the this 2013 study kind of thinks it might have begun a little bit earlier than the original reports. So that would place that as about a 4-hour window. The supercell then likely produced another significant tornado soon after the main tri-state one occurred, around 6 p.m. in southeastern Indiana. Convection had gradually increased in the warm sector of the supercell's life cycle, and it may have become embedded within a line of an echo wave pattern. And so by the time it reached south central Indiana, we had this line echo wave pattern, which I'm not really sure. I didn't look into the details of the meteorological paper, but it seems like that may have played a role in its decay. The supercell is assumed to have decayed, as I said, by 7 p.m. And these estimated times indicate that the supercell's duration was about 7 hours, stretching 413 miles. So obviously we talked about the extremity of the tornado itself, but the cell that it was associated with spawned another tornado shortly after, and the cell itself could have lasted about 7 hours and 413 miles. So
I think that's probably one of the most insane supercells I've heard of in a while.
Yeah, it would have been interesting to have, like, if we had radar capabilities back then to truly see what was happening and just track it. That would have been incredible. So
that I don't know if there's been any supercell that's tracked that long since. Not that I know of, at least.
I don't know offhand. So it's always interesting learning about these incidents before we had modern technology, because it always seems to have like a very kind of not a mysterious element, but it's like very interesting to see through the lens of people who didn't have as much information as we do.
Absolutely. I 100% agree with you. And it brings that level of curiosity, because they obviously didn't have the technology to track it. All they had was word of mouth and from the survivors of the event, and passed down through generations. So it certainly is that's a very remarkable story, Sean.
Thank you. So that's the end of my segment. So what are we doing next, Chris? I believe you're going to talk about
I'm going to talk about,
tornadoes.
yeah, I'm going to talk about tornadoes and forecasting. So, tornadoes, we all know tornadoes are really dangerous for their high wind speeds and physical damages associated with that. But tornadoes are also very inconveniently nearly impossible to forecast. Meteorologists have been trying to figure out ways to forecast tornadoes for almost 200 years now in an effort to save lives. Now, because tornado formation, or as meteorologists called tornado genesis, is so intricate and complicated, we still don't understand exactly how it occurs. We have a pretty good idea, but we don't know some of the really specific details of it. There's still scientific research coming out about this, I should emphasize. So instead of deterministically forecasting tornado genesis to occur, scientists instead forecast tornadoes based on probability. So essentially, if you're looking at a weather forecast, and I know this isn't exactly right, but it says it's going to rain next Wednesday or something, and they say 30% chance of rain, you kind of think in your head, oh, that means there's a 30% chance it will rain on Wednesday. This is the idea of probabilistic forecasting. Deterministic forecasting is saying it's going to be sunny today without any other input. It could hour of clouds or so. In order to make a probabilistic forecast for tornadoes, or any kind of severe weather for that matter, we have to evaluate the current environment preceding the severe weather event to see if there's a combination of variables that favors tornado formation. This includes, but is not limited to, variables such as directional wind shear, speed wind shear, or a frontal passage. When a thorough analysis of the given environment and near future environment is done, some areas may have a risk for tornadoes in some of the coming days. So now we have what's called the Storm Prediction Center, or SPC, and the meteorologists here are responsible for determining the risk for severe weather in the US, including tornado risk. I'm going to show a map on the screen, probably somewhere over here. So you can see there are 8 different tornado risk probabilities, ranging from a 2% chance to a 60% chance of there being a tornado within 25 miles of you. So in this particular map, which is Friday's forecast for March 13th severe weather event, which at the time of this recording is tomorrow. Areas in northern Texas and Oklahoma have the highest risk for a tornado genesis to occur. So the main thing to take away here is that this map is describing the percent chance that a tornado will occur within 25 miles of a point. This is nowhere near as accurate as saying that there is going to be a tornado at that point. But this is how the Storm Prediction Center, to the best of their abilities right now, can prepare the public for a tornado outbreak. So the most important part of tornado forecasting is short-term forecasting, or forecasting on the same day. Now, when dealing with thunderstorm forecasts, it's impossible to say a day ahead of time, oh, there will be a thunderstorm passing through between 2:30 and 3 o'clock that day, because we don't know exactly where these thunderstorms will form. We know the general area of where they are likely to form, but the specific locations and tracks, we don't know that. So it's very difficult for forecasters not only to forecast the thunderstorms, but then to figure out which of those thunderstorms will produce supercells that will produce tornadoes. You can see it becomes very complicated very quickly. So what meteorologists do is, as soon as there's a sign of a tornado on a weather radar, they send a warning. So meteorologists use a radar product called dual polarization radar. And essentially what that does is um, it gives a output in two colors. Um, and one color is winds that are away from the radar, and the other color is winds that are towards the radar. And a way you can use this radar to spot a tornado is if you see both these colors swirling around a very, very uh, little point, very bright contrasting colors as well. And when you see a very tight section of green and red right next to each other, there is a very good chance that there is a tornado there. And when meteorologists can see that there's a tornado, they immediately send a tornado warning. And given that tornado warnings may be issued with very little warning, it is really, really important to get to safety as soon as possible. Later in our show, we will have a emergency preparedness major from our school to help explain how tornado warnings work with us. So stay tuned for that, folks. Now, it's on to our weather discussion. All right, everyone. Welcome to our map discussion. And what we're looking at here is just a precipitation map. You can see there's some snow associated with the Rockies in Colorado. We can also see a horizontal, pretty much, band of precipitation outlining the Oklahoma, Kansas, Arkansas, Missouri, and Tennessee, Kentucky borders there. Looks that storm's taking a geography class, I think. Yeah, we can see a low pressure system looks in New Mexico or Arizona. That's probably more towards Colorado. And so what we want to emphasize, we were just talking about in the previous segment that there would be severe weather in Texas on Sunday. And since today is Saturday, I just wanted to show that a little bit in the map discussion. So I'm looking at a high resolution model, the NAM 3-kilometer model to be specific. And this is one rendered solution of what the projected atmosphere will be like over the next coming days. And so we can start to see a squall line forming across western Texas early into tomorrow or later today. And we can see so the snow has strengthened over northern Colorado up into Wyoming. And the Storm Prediction Center was highlighting essentially this area of northern Texas as the highest risk for a tornado formation. And so in the spot, likely preceding the storm, there would be good variables or variables that would favor tornado formation in this area. Like wind shear and a frontal passage moving through. So usually when you have a squall line like this is indicative of a front. And I believe that this is a dry line and not a cold front. For those who are unaware, a dry line is a front that separates moist air from dry air. And we can see this in this map. And this is a map of what's called precipitable water. And essentially what this is how much water can fall out of the sky at any certain point. And the blue colors is a very moist air that's coming from the Gulf of Mexico up here. And then these brown colors are very dry air. And from looking at analyses, the map is a little messy, but just take my word for it. I'm not going to show it here. But the dew points in this brown area are around 10 to 15 degrees Fahrenheit, while the dew points in the blue and green area over here is around 60 degrees. There's a very, very sharp gradient, as meteorologists call it, of a dew point. And that's creating an unstable environment for these severe thunderstorms and tornadoes and very likely hail to form. So I'm going to go back into um, the precipitation map, and you don't think of a snowstorm having a severe weather aspect, but low pressure systems are really good multitaskers. So they can have a squall line at the same time as producing 2 feet of snow in northern Colorado and Wyoming. So as we go through the day, we can really see the squall line strengthening. The snow looping in on the back end in Colorado, they're going to get upwards of 2 feet, even in down the mountains. On the mountains, they were looking at I can't remember if it was 91 inches. 91 feet seems way too much. I think it was 91
Yeah.
inches of us.
That's a lot
It's
of
a
snow.
lot of snow
That's a lot.
up in some of the Rockies. I don't know if that'll ever melt over the summer. But these high resolution models are really useful for meteorologists in predicting severe weather. Um, Essentially, if we were to look at more of a countrywide forecast, this is the GFS model, which is not as high resolution, but it's also better for long-term forecasts. And so it doesn't render this squall line as much as the NAM, the North American Mesoscale model does. But I just want to emphasize big chance for severe weather across northern Texas and western Oklahoma today. And for those that have been looking for severe weather, this is our first big event of the year. So I want to move into more of a countrywide forecast. And right here, we're looking at precipitation, essentially, and a lot of other lines. What's really important, or not really that important, but keep in mind this blue line that's not dashed, this is what's called the 540 decameter height. Meteorologists estimate this line as the freezing line on the surface. It's not always entirely accurate, but it gives meteorologists a good idea of where it's cold and where it's warm. This is where it's these lower heights. We have 534, 522 up here. That's usually the lower this number is, the colder generally it will be. And the higher the number is, the warmer it will be. Now, it doesn't always follow these rules because this snow is occurring in heights over 540 decameters. But I digress. Generally, it's cold up here and it's warm down here. And as the storm system moves through, this likely spins out as we see a new storm system hitting the northwest into northern California. What looks like a trough over here is expanding into the northeast, keeping us cold as always because we don't want to get in on the warmth action the rest of the country's getting. And so we can see, what is this? This is Monday afternoon. This storm system will move eastward, bring snow into Michigan, and dissipate this render. It dissipates by the time it hits Albany. So we might get a little bit of a snow shower or a rain shower here, but not expecting too much. And if we're going to look at the rest of the week, Wednesday will likely be dry, and it's looking like there will be another storm system forming in over Missouri at this time. We also get a little bit warmer. This 540 decameter line goes northward into Canada, and so at the end of this week, we'll likely see a rain event from this storm. At this point, we don't know much details. This particular rendering looks like a pretty significant storm lasting well into Friday. So this is Friday afternoon. It looks like we're going to get some back end snow with this and another cold air mass moving through. But let's look at the temperatures. Let's see if they follow this line. So essentially, where it's blue, this blue line is separating freezing temperatures. We're getting to the blues and pinks from warmer temperatures, which are greens, and into the reds and yellows in the southwest.
Yeah, this is 925 hectopascal height, correct?
Mm-hmm. Yes, this is 925 hectopascal height. So this isn't the temperatures on the surface, but it gives a good idea of the air masses that are associated with the temperatures. The surface temperatures will be a little bit more variable and a little bit harder to follow, but this will give you a general idea of whether there will be cold air or warm air in your area, which is, you can adjust your forecast based on whether you're in a valley or on top of a mountain. And so as we move into over the weekend, this cold air is pretty stubbornly over New York. And this storm system was moving through. As cold air expands into New York, we're looking at lows on Monday and Tuesday in the teens, wind chill values in the negatives that night. These nights, I believe, Sunday and Monday night. So stay tuned for that. I know it's been warm this week. We can thank Ross Lazier for bringing us warmth, but Chris is back giving us cold weather again. So maybe we'll have to have you do the map discussion next week, and hopefully it'll be warm, Sean.
Hopefully, I'll have that impact on it.
But I am stubbornly keeping the cold air over New York at this time. And it's looking like over the course of this week, they were getting into Wednesday now, the cold air will move out a little bit and we'll tap into some warmer temperatures as this storm system, which is located over Missouri, kind of moves into the area.
Oh yeah, look at that warm air advection. Warm air advection ahead of.
Oh my goodness. I hope there's like a brief warming there.
Yeah, looks like we might get some brief warming just before the low passes to our east.
Yeah. And then as we get into the weekend, it looks like we're going to get another cold layer of air moving through. But at this time, I believe it's 7 days out at this point. So it's kind of hard to forecast the exact temperatures at this time. But we can generally say that if this model rendering is accurate and has a storm system moving through the area, especially as strong as this is a really strong storm.
Look how strong the wind barbs are behind it.
Oof. I know. If we're looking at how close these lines are together, essentially, the closer these lines are together, the stronger the wind will be. So it won't be very windy across the plains at this time. But over in northeast in New York, it will be very windy behind the storm, which is helping to bring a lot of cold air in from Quebec and Newfoundland. The cold air should stay up there, but yeah, we're looking at a very, very deep cold air advection into next weekend. That will be chilly. So don't get too excited about spring yet. We still got winter has its last fighting chance as we get into next weekend. You have anything to add, Sean?
That sounds pretty good. I'm interested to see what we'll see next week for episode 4, what the map discussion will bring.
Absolutely.
Hopefully warm air will follow behind that cold air advection next weekend.
Usually that's what happens. I don't want to play around too much.
Yeah, hopefully an exceptionally warm. That's what I'm hoping for.
Yeah, at this point the models aren't accurate, but it's keeping the cold air in the region. If we're looking at a 7-day forecast for Albany, I'm just going to run through this quickly. We got highs in the upper 30s over this weekend, and Monday will be a little bit chilly. Looking at low of 11 on Sunday night, and into Monday night 14. Tuesday, Wednesday, we're getting into 50 degrees, so we might get a little touch of warmth again.
Definitely more seasonable by midweek. Definitely looking forward to that.
Mm-hmm. But yeah, we're looking into 30s for the next 4 or 5 days, and then nearing the end of the week before that next storm system moves through, we're looking at almost 50. And then once that next storm system moves through, it looks like it's going to be very cold following that. So we might be wearing coats next week during the weather booth. All right, folks, on to our next segment.
Tornado safety is an extremely important topic to us here at the Weather Booth, as many people lose their lives every year to tornadic disasters. To help prepare you for tornadic events, we invited Pete Tedeschi on our show today. Pete is currently a junior at the University of Albany, who is double majoring in atmospheric science and emergency preparedness. Now let's give a warm welcome to Pete.
Thank you for having me, guys.
No problem. Can you introduce yourself a little bit, Pete?
Sure. So I'm presently a junior at the University of Albany studying atmospheric sciences and emergency preparedness.
Why did you decide to major in emergency preparedness?
I decided to major in emergency preparedness in addition to atmospheric science because weather safety is a critical component to me, and FEMA is actually a major contributor to emergency preparedness, and they both go hand in hand. So I figured that's going to be a good pairing.
They do, I agree. They do go very well together.
So what are your career aspirations, Pete?
Sure. So my career aspirations are to work for the federal government, either at FEMA or NOAA or the National Weather Service. And since I just said, atmospheric science and emergency preparedness go hand in hand, so I could help out both agencies in the best way I can, and ultimately improving the tornado survival rate.
What is the biggest hurdle when trying to prepare people for severe weather?
I would say people taking the warnings seriously, since most people would not see the warning on their phone in a timely manner. And they would say, the last time I had a tornado warning, nothing happened. So I'm not going to really take this seriously.
I do the same thing. I'm not going to lie. So do you have any suggestions or tips for people to be better prepared for a tornado?
I do. So people can obviously prepare an emergency kit, much like how they would have an emergency kit for floods, getting stranded in a car. That same concept should be carried on into tornado warnings, which should be in your internal hallway on the lowest possible floor with as many walls between you and the outside. And that kit should have enough food to last you for a few days, water, a flashlight, and some activities to keep you entertained for the duration of the storm.
Yeah, because it seems like a lot of people forget that sometimes if you're actually impacted by tornadoes, it could affect you for like days. Like it'd be a while before you fully get back into like the recovery mode. You're still like getting through it. So definitely very important tips in preparing for a possible tornado. So how do you think we can improve emergency preparedness for tornadoes in the future?
Sure. So I think that people should definitely hold tornado drills. They're similar to fire drills in that they basically go off all at once and people are expected to react in a timely manner. While they're not common up here in the Albany area, they're more common out towards like Oklahoma and Texas, where tornadoes are more common. And they're essentially mock tornado warnings, where people generally on the first Wednesday in the month of March, where people all across the state go in and take shelter in their safe area.
Are there any steps that have been taken recently to better prepare emergency preparedness for tornadoes?
So the Weather Service itself has actually released new guidance in the last couple of weeks to essentially change the way they're going to do their warnings for the tornadoes. And that should be released about 2024. The current timing for tornadoes warnings is about 17 minutes. That's not enough time because you have to get your family, your pets, everyone into that same safe shelter I mentioned before in order to ride out the storm. Research is constantly being done to improve the forecasts. Here on campus, a lot of forecasters are doing that, and nationwide. So, and every year they come out with new guidance to improve that even more.
I know while I was talking earlier about how they were, they're still trying to figure out exactly how a tornado forms. We have a general idea, but we don't know the exact specifics about it. So Pete, really appreciate you being on here today. Weather safety or tornado safety is really important to us. So we're very happy to have you. So thanks, Pete.
Thank you so much thank you for enlightening our viewers and ourselves.
Absolutely.
See ya.
So in today's episode of Weather Booth, we focused on tornadoes. First, I talked about the deadliest tornado in U.S. history, the tri-state tornado.
And I talked about how the specifics of tornado forecasting, and we did a little map discussion describing the severe weather event coming up soon. And we also had expert emergency preparedness major Pete Tedeschi talk to us about how to be better prepared for tornado emergency.
And that's the end of today's episode of Weather Booth. Stay tuned until next week when we talk about derechos, and we have an interview. We'll keep that a secret until the start of next week's episode. But until then, this has been Weather Booth.
This has been the Weather Booth.